What's up, guys? So we're going to be doing another Elixir Getting Started guide section today, and that section is Comprehensions. So it'll be a lot of fun, a lot of cool examples to run through, and yeah, we're just going to code it up a little. I gotta mute my phone, it's making noises. All right, guys, well, let's get started. I'm going to go ahead and open up Safari, and we'll go to elixirlang.org. Let me share my screen. All right, and we'll make this a little bigger. And we're going to head over to Guides. And then on the left-hand side here, let's find Comprehensions. All right, cool. Hey, welcome, Daniel. Glad you're joining us. Hey, thanks for hanging out with me. These are a lot of fun because I feel like it's like rare you fully read through documentation. And so this is forcing me to read it, and it's helping other people read through it too. So it's fun. Let's go ahead and start. So in Elixir, it is common to loop over an enumerable, often filtering out some results and mapping values into another list. Comprehensions are syntactic sugar for such constructs. They group those common tasks into the for special form. For example, we can map a list of integers into their squared values. Let's go ahead and pull up our terminal here. Whoop, opened on the wrong screen. Let's make this a little bigger. Cool. All right, so we're going to just start our IEX shell, and we're going to just go through an example here, and we're just mapping through a list of integers into their squared value. And so we can use the comprehension with the for special form. So for, and then we have the n, and then we have the left arrow or the assignment operator, I guess it would be called. And then we have our list here, and we're going to make a list of 1, 2, 3, and 4, and close that list off. And then we need a comma, do, colon, and then we're going to, as we iterate through the list here, we're just multiplying the value by itself. So we are squaring each value through the list, and when I hit enter, we get our values squared back. So a comprehension is made of 3 parts: generators, filters, and collectables. Let's go. So generators and filters, in the expression above, the n and then the assignment operator, and our list is the generator. So this is literally generating values to be used in the comprehension. Any enumerable can be passed on the right-hand side of the generator expression. So any enumerable can be placed where our list is here. And so we could also use ranges. So let's go ahead and play around with a range. So we can say for n and then the assignment operator, and we can do our range, which is 1.4. So this will be values 1 through 4. And then we can do the same thing, n times n, and we get the same values back. So generator expressions also support pattern matching on their left-hand side. All non-matching patterns are ignored. So imagine that instead of a range, we have a keyword list where the key is the atom, good or bad, and we only want to compute the square of the good values. So this is cool. You're starting to see that we can pattern match to filter a little bit. So it's a superpower. And so we're going to create a values list here and assign it to the values variable here. So we're going to create a list, and we're going to have a good key with a value 1, and then another good key with the value 2, and then we're going to have a bad key 3, and then another good key 4. So our keys are atoms. When I say key, I just mean atom. And when I hit enter here, we now have this list binded to our values variable. And we can now do the for, and we can pattern match here. So we can have a tuple, and we can say, look, any left-hand variable that is equal to the atom good will match, and then we'll assign the value to the variable n. And then we have our left arrow, our I forgot what I called this already, our assignment operator. All right, and then we're going to pass in our values list to iterate through, and then we're going to do the same thing. We're squaring each value, so n times n, but this time it's going to ignore 3, so we're going to go from 4 values down to 3. And there you go. So only when the atom or the key equaled the atom good did we square our values. So we got 1, 4, and 16 back. All right. Whoops, what did I do? Just clicking. So alternatively to pattern matching, filters can be used to select some particular elements. For example, we can select the multiple of 3 and discard all others. So here we're adding, let's see, we didn't do this here, did we? Yeah, so if you notice, we have our generator here. So we have our generator here, and now we're adding our filter here. So let's go ahead and jump back into our shell and try out this example. So we're going to say for, and then our generator is n. And we are doing just a range of 0 to 5. And then we're going to take the remainder, so we're going to say n. So we're doing anything multiples of 3. So the remainder is taking in our value n, and then as long as 3 is divisible, so we're looking for a value, the remainder value needs to be equal to 0. And if it's equal to 0, that means it's divisible by 3. And then we're going to do this, we're going to n times n, which is our squared value. And now we're going to get, let's see, we're going to get a value back for 0 and 3, right? Because 3 is divisible, and then 3 times 3 is 9, so we'll get 2 values back. We'll get our 0, and then our value 3 got squared. So that's pretty cool. So comprehensions discard all elements for which the filter expression returns false or nil. So that's good to know. So our filter, obviously this one is returning true, but so anytime that it's false, it's just discarding. So it's not completing the execution here. So all other values are selected. Comprehensions generally provide a much more concise representation than using the equivalent functions from the enum and stream modules. Furthermore, comprehensions also allow multiple generators and filters to be given. Here is an example that receives a list of directories and gets the size of each file in those directories. All right, so this is cool. We can let's see, we can pass in more than one filter. Wait, let's see. Furthermore, comprehensions allow multiple generators and filters to be given. So we're creating a list of directories. All right. And we're going through these directories. So our generator is here, a list of directories, and then one at a time. And then we're listing the files, and we're getting our file back. So this would only work obviously for, let's see, file.ls, the directory, and then we get our file, and then path, we get our directory and our file. Okay, so we're going through and we're grabbing, I believe we'd be just grabbing the first file in this directory, and then we're getting the size back of that file. So that's pretty cool. I feel like let's make an example so we can actually do this. I'm going to pull up our terminal here, and we're going to want to leave our terminal. I'll clear this so we're on top. I'm going to just cd into the desktop. And then we will, let's see, I guess we'll just create, well, let's make a directory. We'll make a directory and we'll call this example1. All right, that popped up on my desktop. And then we'll make another directory and call it example2. And then let's cd into our first directory here. So example1, and then we'll create a file. We'll say touch and we'll say file1. Okay, so that has a file. We'll back out and then let's go ahead and just say touch, and we're going to create a file in directory 2, and we're going to call this file2. All right, cool. So now if we go into example2 directory, example cd example2, and just list all the elements here, you still see file2. And then I'm going to clear this so we can see everything. And let's see, I'm going to just copy and paste. Let's put some stuff in these files so there's a size. I'm going to just copy this example. And let's go ahead and say vim file2, and then we'll just insert, all right, and then escape, right, and quit, and then back out, and then we can also do vim example1 file1, and we'll make them slightly different sizes, right? We'll just grab a chunk of text here and insert that, and then write and quit. All right, so now we have files. We have a path and we have files with things in them, and now we can go ahead and play around with this cool example. So we are going to find the size of the file in our directories list. So let's go ahead and pull up our shell again. And I'm not going to forget to start it. So let's start it. I'm going to clear so we're at the top. And we're going to make a directories list and bind it to the variable name dirs. And right now we will, all right, put a quotation mark. And we're going to just put, there we go, put our directory right there. And then comma. And then these are inside double quotes, okay? And then I'm going to just drag that in there. Whoops, and then let's close off. So now we have our list of directories with our files inside of them. So boom, there we go. And now we can do our comprehension where we're going to iterate through our directories, and we're going to grab the files out of each directory, and then it should return the size. Now, I really hope this works because, you know, doing things live, sometimes code doesn't work. So I'm going to do 4, and then we're going to assign, use the assign operator here, the left arrow, and we're going to go through our directories. And this is going to be multiple lines, so hopefully I don't have any typos here. All right, and then we're doing another generator. So we're doing file.ls. And, you know, I guess actually since we're doing multiple generators, it would work with multiple files inside, because this is another generator. And now we're going through the directory to get each file. So that's pretty cool. And then we're going to take that path and we're going to say path.join. And then we're taking our original directory path and then adding the file to that path. So we're creating a directory all the way to the file now. And so that's what path.join does. It's just an easy way to do it. Like we could write an entire string. So we could have our users Jacob Blitzo desktop example1 / file1 if we wanted to. But this is just a better way of doing it. All right, and then we're going to say file.regular, and we're going to send in our path. And then if that is true, we are going to go ahead and return the size. And stat returns a lot of information like the info of the file. So what we're doing here is we're just passing in our path for our file, and then we're just grabbing the size out of it. And then when I hit end, we should get our sizes back for each file. So that's really cool. So look at that. We have 2 directories and the size of each file. So that's cool. Let's go ahead and continue onward. So multiple generators can be used to calculate the Cartesian product of 2 lists. So let's see, we have a generator that's going through a list of atoms here, and then we have another generator that's going through a list of numbers. And Cartesian product, if I recall, like looking at the results here, what it will do is it will return every possible arrangement between the 2 sets that are possible. So we obviously have 3 elements in one, 2 in another. So every A arrangement with this other list, we get 1 and 2. So there's 2 possibilities. And then B, there's 2 possibilities, and C, there's 2 possibilities. So it's just returning every possible order that is available, if that makes sense. I feel like I'm doing a horrible job explaining it, but it's kind of out of the scope for this. But we'll just run through this example, and what we're seeing is basically every possible pairing that's available back at it. Sorry for the ramble. Hey, what's up, Default? Thanks for joining, man. So we're going to do 4, and then we're going to pass in our first generator and assign our list of atoms. So A, B, and C. And then we're going to do our second generator and assign those to J. And that is going to just be values 1 and 2. And then and then we're going to just return a tuple with I and J. And this is going to give us all of our possible arrangements back. There we go. So that's cool. And now bit string generators. So bit string generators are also supported and very useful when you need to comprehend over bit string streams. The example below receives a list of pixels from a binary with their respective red, green, and blue values and converts them into tuples of 3 elements each. All right, so we're taking a binary, a bit string of pixels, essentially, right? And what we're doing here, it looks like we're taking 8 bits, 8 bits, 8 bits, and assigning it to RGB. So it's taking the first 3, the next 3, and the next 3, and it's returning back these pixels in an organized fashion. So we have the RGB values. So that's cool too. And let's go ahead and jump back into our shell. So if we want to just create our bit string, or our binary of bit strings, right? So pixels, and then we'll set that equal to, so double chevron, and then we have our 213 value, 45, 132, 64, 76, 32, 76, and then 0, 0, 234, 32, and 15, and then double chevron. And now we can say, so 4, and then a little bit of pattern matching here. We're going to set R to the first 8 bits, and then G to the next 8 bits, and then B to the next 8 bits. And then the assignment operator. So this is our generator, right? And then we're passing in our pixels variable. All right, and then if you notice, all of this is happening between the double chevrons because it's a binary value. And then we can say do and return our tuple with R, G, and B in it. And now when I hit enter, we should get our list back, and we've separated our binary into a bunch of 3-value tuples. So a bit string generator can be mixed with regular enumerable generators and supports filters as well. The into option. Let me make sure no one's talking. Hey, AI Combo, welcome, man. Glad you're here. So the into option. In the examples above, all the comprehensions returned lists as the result. However, the result of a comprehension can be inserted into different data structures by passing the into option to the comprehension. For example, a bit string generator can be used with the into option in order to easily remove all spaces in the string. Okay, this is cool. All right, so here we are. Let's see, we have our for form, and then inside of our bit string, we are assigning to the letter C. We're passing in a string with a space in front of it, hello world with a space between them, and then a space at the end, and that is our bit string. And then our filter here is as long as C is not equal to the, let's see, the, why am I blanking on this? It's not the ASCII value. What am I looking for here? Well, anyways, the question mark in front of backspace S is returning the numerable, the integer value of space for us. So this is just, it is a, why am I blanking on this, guys? This is going to drive me nuts. Maybe one of you can help me. Good evening, perfect tutorial. Can you please do a drag and drop? Maybe someday. I am going to look up, what am I looking for? Char lists. Sorry guys, here we go. The code points, the Unicode, that is the word I was looking for, and it was hurting my brain. So we're, as long as C is not equal to the code point of space, and if it's not equal, it's false and is ignored. And if it is, then we're going to turn that into a no space. All right. So back to our terminal, and let's see. Now, if we do the into option here, and we're just going to say, so if that is true, we want to replace a space with no space. So just double quotations next to each other, and then do, and then we're just returning our bit string back. So, and there we go. So we get hello world with all the spaces removed. Pretty cool. All right. So sets, maps, and other dictionaries can also be given to the into option. In general, into accepts any structure that implements the collectible protocol. A common use case of into can be transforming values into a map. All right. So we're taking a map, and we're going to get the key and value, and then we can say we want a map returned, and it returns a map with our values squared. All right, so let's go ahead and do this. So for, and then we're going to just pattern match to the variable name key and val. And then our assignment operator here. And then we're just passing in a map with the key A. And that is set to value 1. And then we're going to do key B. And that is set to value 2. And then let's close off this map here. And then we can say into, and we want to return a map. And then we can say do, and then we can return the key and the value squared. So value times value. And now when I hit enter, we'll get a map back. So there you go. Otherwise, it would have returned, let's see, like up here, it returned a list of tuples. Now we're returning our map. So we get our value and our values back in a map, a key value map. So that's really cool. All right, so let's make another example using streams, since the IO module provides streams that are both enumerables and collectibles, an echo terminal that echoes back the upcased version of whatever is typed can be implemented. Oh, that's cool. This is going to be a cool example. Get ready. All right, so clear so you guys can see what I'm doing. Okay, so what we're doing here is we're assigning a variable to, or we're creating a variable called stream, and we're setting that to io.stream, and it's a standard input output, and we're passing in our line. So we're setting a stream to whatever line that we're typing in, right? So that's there. And now we're going to do our comprehension. So for, and then line, and we're setting that to our stream. Okay. And then we want to return. So we're doing the into option. We want a stream returned to us. Then we open up our do block, and we're going to just say string dot uppercase line. So any line typed, we're going to uppercase every character. And then we're going to concatenate a new line at the end. So everything we type will be put on a new line when we hit enter. All right, so I think this is probably going to get us stuck in a never-ending loop, but it says that in the let's see. Yeah, unfortunately, this example also got your IEX shell stuck in the comprehension. Yeah, so I'm going to hit enter. This is going to be cool. All right, so you can see that it just looks like it kind of broke and froze, but I bet now if I write Elixir mentor and hit enter, that's cool. So it's returning whatever we type, all caps. So Jacob, hello, dope. All right, cool. That's pretty cool. And to get out of this, we'll have to hit Control C twice, and we're out. All right, that was awesome. This was a really good section. So other options, comprehensions support other options such as reduce and unique. Here are additional resources to learn about comprehensions. All right, so this is a pretty good article. I scanned through it earlier today. I linked this in the description below as well, and I suggest checking it out. It's pretty good stuff, and I am following. All right, so that was a lot of fun, guys. I am following your Elixir tutorials. I love the Elixir Gist Phoenix tutorial. I have to tell that it is perfect and have learned a lot. I have switched from Django. That's awesome, man. I love hearing that. And I just love when people like my tutorials. So that's really cool. So that was the comprehensions section of the Elixir Getting Started. A lot of fun. And next week, Tuesday, we'll do sigils, and that'll be fun. And then the following Thursday, we'll do try, catch, and rescue. So that'll be a lot of fun as well. And tomorrow, we have Sasha Jurish, I think it's Jurish, the author of Elixir in Action, coming on the Elixir Mentor podcast. And I normally live stream at 10 a.m., but he's, in a different time zone, and we are doing it a little earlier to be a little more convenient for Sasha. So we're going to be doing that at 8 a.m. Mountain Standard Time, and it's going to be a good one. I'm really excited for it, and make sure you guys tune in for that one. And as always, guys, thanks again for hanging out with me and going through the comprehensions section of the Elixir Getting Started Guide. Thanks a lot, guys. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. An Ash tutorial. That's definitely going to happen. I'm trying to figure out a good example because I just started playing around with it. I just made the Elixir Mentor blog using Ash, and that was a lot of fun. And I can't find the theme you use in. It is called the Elixir theme. Here, let me pull it up. VS Code. New window. Oh, I should share my screen. It is called the Elixir theme. Let's see, where is it? I'll just search for it. Elixir. Theme. Huh. Well, I don't know where my theme is. Oh, here it is. Elixir theme. I don't know how to say that name, but here it is. So dive on in, guys. It's a good one. I like it. And it's funny, like out of coincidence, it's called Elixir theme, right? Because I just like the colors of it. But it also works out that it's called Elixir, right? Yeah, so Ash tutorial's coming. I'm thinking of some good ideas because I'm just learning it. I made my blog post with it. Phoenix Ash, I have to tell. Yeah, it is going to be a sick podcast default. I'm excited. I can't find the theme. Okay, I want to contribute if I can help any. Yeah, our AI combo, are you in the Elixir Mentor Discord channel? If you aren't, please join and reach out to me, man. Because I have a lot of questions. I struggled picking up like how I had to go through a lot of code examples, like the Ash Twitter project that why am I blanking right now? That Zach Daniel created. I was blanking on Zach for some reason. But yeah. So yeah, I'm looking for good ideas. So if you guys have a good project idea that I can do, I'm trying to figure that out. And then I'm definitely going to dive into doing some Ash tutorials because the speed that I built my blog at without knowing how to use Ash was pretty remarkable. So that was pretty cool. You're welcome, Leandro. It's the bottom left corner. Settings. Oh, yeah. Let's see. Oh, yeah. That's way easier to do it that way. Elixir theme. Yeah. Not yet. Yeah. AI combo, join Discord and let's chat for sure. And I can always I love having people that are learning and know things because then it helps me answer some questions in there as well. So, all right, guys, thanks so much. Can you make a video talking about performance? I really should. So Ben and I, with the Big App Energy podcast, I don't know if you caught that episode. We just talked about SEO and site performance. So maybe, I could go through using like Unlighthouse and some of those tools to run on your own site, and then we can run through fixing some things because I use it all the time, and I've been slowly tweaking Elixir Mentor to be a more performant site. So that wouldn't be a bad idea because I think a lot of people use JavaScript too much on the front end. Like obviously it's good to use for animations and a lot of stuff, right? But every script that you're calling on the client side slows things down. Well, I'll eventually do stuff with OTP agents and like gen servers. But if you really want to, and check out my Elixir comprehensive introduction course, It's for sale on indiecourses.com. And if you use the code MIX25, you get 25% off right now because I'm still releasing stuff. And I have like 10 hours of content. I'm about to release the Erlang and interoperability module, which will be probably about 4 videos. I'm just finishing up recording. So that'll be a good section. And then I just have to finish planning out the final project there and get that all recorded. And once the final project's done, it's going to be full price after that. But yeah, GraphQL, kind of currency exchange server. Yeah. Are you talking about for doing like an Ash project? That could be cool. All right, guys, I'm going to go. This was fun. Thanks for all the questions. And if you're not in my Discord studio or server, please join. Come chat with me. Come chat with everyone that's in there. We love having more and more people. It's cool seeing my server grow every day. So, all right, guys, thank you so much for tuning in. And I will hopefully catch you guys tomorrow at 8 a.m. with my chat with Sasha. See you guys.